Welcome to Study Loop.
In this experiment, we are using light of wavelength 612 nanometers, but this is the wavelength of light in vacuum. So because our apparatus is underwater, we have a new wavelength, let's call it lambda again. The diffraction slit width is, in this case, 0.00125 millimeters. And we are given that at a distance of 30 centimeters, the diffraction, the width of the diffraction first, the diffraction bright band was 22.4 centimeters, which means this distance is 11.2 centimeters. So the angle theta corresponds to d sine theta is equal to m lambda, where m is 1. So theta is sine inverse of So before we go ahead, let's now we know that sine theta, we know that in this case tan theta is equal to 11.2 by 30. So sine theta is simply sine of tan inverse of 11.2 by 30. And by plugging this into a calculator, we'll see that it is equal to 0.35. So by plugging it here, we know that d is 0.00125 meters. So that is 1.25 into 10 power minus 6 meters times 0.35 is equal to lambda. Therefore, lambda is equal to 0.437 into 10 power minus 6 meters, which is 437 nanometers. So now that we know this, we simply use the refractive index is equal to wavelength in vacuum, which is 612, divided by wavelength in nanometers divided by wavelength in the medium, which is 437 nanometers again. So that is 612 divided by 437, which is 1.4. So the refractive index of our material is 1.4.